In this area, we can establish a base camp because we have everything we need. We also rely on the environment. We get oxygen from the environment. We get water. We get wood for fire from the environment. Well, now let's imagine colonizing Mars. On Mars, we also rely on the environment. Colonizing Mars is going to require using the oxygen from the Mars atmosphere that we could derive from the carbon dioxide, growing food on Mars, getting water from the atmosphere on Mars. The same mix of resources from the environment and material that we brought with us is what's required to allow us to successfully colonize space.
Once the base has been established, the primary objective of early missions is to search for evidence of life in the past and the present. Using radar, astronauts attempt to locate groundwater within a few hundred yards of the surface, then bring it up with drilling rigs. Samples will be studied under microscopes in the crew habitat to see if they contain evidence of life. If the planet proves capable of supporting life, then it would be viable for astronauts to construct greenhouses and cultivate crops using Martian water, soil, and sunlight. As they search for life, these pioneering astronauts will have to contend with the one force that could bring the lofty ambition to colonize Mars back down to Earth. That's gravity.
The gravity on Mars is 1/3 the gravity on Earth. We don't know if that's enough gravity to allow for healthy bones and muscles. If Mars gravity is not suitable for human long-term survival, then it may become the place we visit. We may go there for a week or so. It's a tourist attraction, but it's not a home. And so that's a fundamental question that needs to be answered. Is 1/3 gravity enough gravity for us to live biologically fit lives? My guess is the answer is yes, but we have no direct data, so we can only guess.
Discovery and Alpha, capture confirmed. And ISS is in...
Getting direct data will be vitally important.
Houston, copy.
So will communicating it to Earth. The lag time in radio communication between the Mars crew and mission control, as much as 40 minutes depending on planetary alignments, will affect how the astronauts conduct their research.
It certainly means that the Mars crew is going to have to be a lot more autonomous than you could have with human crews in Earth orbit or on the Moon. You're not going to be talking to the Mars crew, okay, now step 2 steps to the left and head towards the rock. They are going to have to make their own decisions, and I think more generally the Mars mission is going to have to be led from the front, and that the commander of the Mars mission will be in the Mars mission, and rather than have mission control, we will have mission support on Earth.
Good luck. Back to work now. Back to work, all you guys.
The habitat that will house the astronauts offers a preview of structures that could form the first settlement on Mars. As proposed in the Mars Society's direct plan, the initial habitat will be the crew vehicle itself. The tuna can, as its proponents call it, is about 20 feet tall and 27 feet in diameter. It has 2 decks, the upper level for cabins and a common area, the lower one for lab and workspace.
We have found in our field work that while these are tighter quarters than most Americans are used to living in, they're not that bad. You don't really feel that crowded. We tend to keep the private bunks very small so that we can maximize the public space, you know, the wardroom where people hang out. If you've got a healthy crew where the people want to associate with each other, then this is clearly the best way to ration the available space.
As more pioneers settle on Mars, it may be safer to move the growing community underground.
Because it's a terribly dangerous place. There are sandstorms that can hit and knock over any surface establishment. There's horrible ultraviolet cosmic rays effects. You're going to want to save people's lives, save their reproductive abilities. You're going to want to have a place where you can raise children. You're not going to do that at the Martian surface. You're going to be doing that underground. Under those circumstances, it would be more like vast urban malls, probably very nicely lit, nuclear and solar power. It shouldn't be a terrible life, providing that they get to a tipping point in technology, a tipping point in support from the outside world.
Early missions to Mars, if conducted during optimal planetary alignment, will last approximately 2.5 years. That includes the 6 months to get there, a 1.5-year stay on the surface, and the 6-month return trip to Earth. During that time, we will know whether Mars can support life. If it can, that opens the door to the ultimate form of colonization. Terraforming the planet to make it more like the Earth. Once humans establish a self-sufficient base on Mars, the next major advance in space colonization, say advocates, will be to terraform the planet, a process that will make Mars Earth-like. Wherever humans have settled, they've remade the environment to suit their needs. Mars may not be any different.
Terraforming is perhaps the ultimate way to create a new Garden of Eden in outer space. And how would we do it? Take a look at Mars. Mars is a frozen desert. First, we would have to raise the temperature.
We know how to warm up planets. We're doing it right here on Earth, where it's not a good thing, whereas on Mars, it would be a good thing. So in fact, we could do the same things we're doing on Earth, putting in the atmosphere greenhouse gases, which would cause the planet to warm. On Earth, that would be pollution. On Mars, it's medicine.
Calculations have shown that the amount of greenhouse gases that we need to introduce to Mars are reasonable. They're not really way beyond what we can imagine to produce. But the amount is also too large for us to bring it from the Earth to Mars. That means that those gases have to be produced on Mars. We would need to set up factories to produce those gases and release them into the environment.
These factories would combine elements taken from the Martian environment, convert them to non-toxic fluorocarbon gases, and vent them into the atmosphere. Experts estimate in about 100 years, these greenhouse gases will have terraformed a cold, dry, dead planet into a warm, wet, life-supporting world.
It's interesting to think about what would Mars look like after 100 years of warming. It would be bluer than it is today. You'd see large patches of water. You start seeing little fringes of green around the margins of these blue areas. And then with time, this infestation of green would move away and up and into the mountains. And eventually, you'd see a world of blue and green with little islands of red that remain, almost like national parks preserved.
Then in the first stages of terraforming, the temperature will rise and also the atmospheric pressure will rise. That will mean that humans will actually be able to go out just in suits that really press down on their skin in order to recreate some pressure and with an air mask. And that would really make it much easier to go outside. It would probably take quite a while for Mars to become really a place like this, where we're in a greenhouse at the Los Angeles Arboretum. It would definitely take a while before we have such a paradise as this. But we can start from very basic algae, mosses, maybe grasses.
While this is going on, genetic engineering of the people themselves could also be taking place, so that you are breeding in, either through selection of your offspring or possibly even genetic manipulation, generations of citizens who need less gear when they go out on the Martian surface. Their skin is less fragile to the ultraviolet, to the low-density atmosphere. And eventually, they just need their respirators less and less. As the atmosphere increases, so does their ability to meet the atmosphere halfway. And these would be the beginnings of the true Martians, the people who could actually make this world their own.
NASA itself is not interested in terraforming planets, partly because it sounds very science fiction-y, but partly because there are real ethical questions involved. You will find a lot of people who believe that human beings should not go into space because we will just destroy things in the way that we've destroyed our own planet, and that we need to preserve the Moon and Mars and the other planets the way they are for scientific investigation.
Whether we should terraform Mars is an issue for future generations to resolve. It's a very distant point on a space colonization timeline that could begin with this generation.
The one thing that we can probably predict is that we will see ourselves in other places of the solar system than the planet Earth. Space colonization will be driven by the normal processes that we've seen over human history of expansion of people from one place to another across frontiers. Space is another kind of frontier. It's a technologically challenging frontier, but the human species has been extraordinarily resourceful over its history in its ability to adapt and to overcome challenges like the frontier of space.
My son, maybe someday he'll follow in Dad's footsteps. And I would be awful proud knowing that you blazed the trail. And, you know, he can do it. You know, next generation, who knows where they'll be.
Space colonization will be the ultimate camping trip. It'll test our equipment, it'll test our planning, it'll test us. But it'll be worth it. We'll learn a lot about space, about our own Earth, and about ourselves.
Whether it happens on Mars or somewhere else, maybe even beyond our solar system, space colonization won't be driven by the desire to plant a flag, but rather a seed. In the future, when we gaze into the heavens and ask, is anybody out there? The answer just might be, yes, it's us.
זה כתוב בתלמוד, בקוראן ובספר ההתגלות.
Chaotic and breathtaking, their beauty forms from the emptiness of space.
Nebulas are everything in the galaxy that stars are not.
Wisps of matter, at times coming together, at others flying apart. Filmy veils, billowing masses, some dark, some glowing in brilliant colors, many taking the shapes of things that are eerily familiar.
It's interesting when people look at nebulas, they sort of start seeing things in it.
Neither stars nor planets, they are the crown jewels of the galaxy. The universe reveals its awesome display of stellar birth, death, and the cycle of creation inside the nebulas. It is one of the most famous space photographs ever taken. As seen by the Hubble Space Telescope, it shows the pillars of creation, massive columns of dust and gas 7 light-years long. As big as they are, the pillars are just a small part of an immense stellar nursery 6,500 light-years from Earth, called the Eagle Nebula. Nebulas of all kinds are scattered among the stars everywhere and are among the most spectacular sights in ours or any galaxy.
Nebulae are beautiful, all of them. They really strike the eye.
From the Greek word for cloud, nebulas are just that. Clouds of interstellar gas and dust, rarely visible to the naked eye. But with telescopes in space and on Earth, their beauty is revealed. Glowing, reflecting, or obscuring the galaxy's light. They are regions where stars are born, where stars die, and where explosions wreck the very fabric of space-time.
Nebulas have fantastic shapes, like clouds in the sky on a summer day. They often evoke imagery that hits very close to home. Images of flowers, images of insects, images of people.
It's interesting when people look at nebula, it's like a Rorschach test. They sort of start seeing things in it.
Although nebulas are labeled with numbers from astronomical catalogs, many also have names inspired by their locations or shapes. It's not difficult, for instance, to see why this is called the Butterfly Nebula, or this is known as the Horsehead Nebula. The list goes on.
The Orion Nebula, the Ghost Head Nebula, the Stingray Nebula, the Helix Nebula, the Cat's Eye Nebula, the North American Nebula, the Pelican Nebula.
The astonishing forms nebulas take make them the tourist attractions of the galaxy.
If you've got the family on a flying saucer and you're careening through the Milky Way looking for an interesting rest stop, you're going to go to a nebula.
Like tourist attractions on Earth, faraway nebulas entice us for a closer look.
Man, it's a hike.
One of the prime attractions in the night sky is the Great Orion Nebula. One of the very few nebulas you can see with the naked eye. On a clear night, it appears as a fuzzy star in the Sword of Orion. Probably the most recognizable constellation in the sky.
The Orion Nebula is the most active area of star formation in our galaxy. It lights up the sky like nothing else. So this is a big one. In terms of nebulas, this is the Hollywood sign.
And the reason why travelers want to get close to tourist attractions is the same as why astronomers want a closer look at nebulas. They each want to take photos. After all, tourism, whether earthly or astronomical, is all about the pictures.
Photographs of nebulas occupy a real special niche, a very important niche, I think, because they really do sit at the pinnacle, the confluence of art and science.
Of course, getting good pictures of a nebula isn't just a matter of point and click. In the mountains north of San Diego, a group of amateur stargazers have an especially tough road to follow in seeking out nebulas and taking great pictures.
It is always worth the long drive to come out here. Night under the stars, even if I don't do any imaging, is worth it, just to see what I can't see from home.
When the equipment is this complex, these enthusiasts aren't just taking pictures. Here, the word is imaging. And their favorite targets are the nebulas.
Just being able to look at them and imagine what's going on out there in that gas cloud, being able to see a sense of where stars are forming, it's just a great kind of a sensory experience to have.
In addition to their portable telescopes, the group has also built a complex of permanent observatories. Inside the enclosure housing their big 20-inch telescope, accomplished astrophotographer Alan Smallbone attaches a special astro camera to the eyepiece. He's preparing to image the Orion Nebula.
It's a very challenging object to me because it has very light areas, it has very bright areas, it has very dark areas, and it's a very difficult item to photograph accurately.
The digital cameras used by today's astrophotographers emulate color vision in the human eye itself. There are 3 kinds of cone cells on the retina, each sensitive to either blue, green, or red light. That's why those colors are considered the primary colors of light. But the retina of an astro camera is a computer chip, sensitive only to black and white. So for color photos, it uses red, green, and blue filters, taking at least one shot with each one. It's often called the RGB technique and is standard for producing more natural color. In capturing the Orion Nebula, Smallbone takes time exposures lasting 5 minutes through each of the 3 filters. But nebulas are so dim that for the best photos, he often needs dozens of exposures, with times totaling as much as 14 hours. No one ever said this was easy.
Astroimaging can be very tedious because it's very time-consuming. It involves long periods of time where you're sitting waiting for the camera, and the mount is just tracking, and there's really nothing you can do except sit and wait.
Later, Smallbone stacks the raw images on his computer. There, the different combinations of red, blue, and green dots work just like a color TV to create every other hue in the spectrum. Hours after first opening the shutter, the Orion Nebula appears in its natural colors on the screen, as no human eye has the sensitivity to see it. The striking images of these and other nebulas demonstrate the essential reason astrophotography is indispensable when it comes to the nebulas.
The combination of a telescope and a camera actually allows you to see details and structures in the nebulae that you couldn't see with your own eye because they're so faint and diffuse.
The Great Orion Nebula is well worth the attention it gets. 15 light years across, it is a massive cloud made mostly of hydrogen. It is the quintessential example of the kind of nebula known as a star-forming region.
It is the cradle of the most massive stars that are born in our galaxy. And it is the closest example of that process to us. So when you look at the Great Orion Nebula, you're looking at stars being born.
Among the thousands of infant stars in the Orion Nebula, 4 of them dominate. The corners of a cluster called the trapezium for its trapezoidal shape. Massive and hot, they are responsible for the brilliant astronomical display.
The trapezium in the center of the Great Orion Nebula is what energizes. It's what makes it a nebula. If you didn't have the trapezium stars, it would be a dark cloud.
Radiation from the trapezium stars sculpts the surrounding gas and causes it to glow with emitted light. What would it be like to fly through the Orion Nebula in a spacecraft? It might look like this. A remarkably accurate supercomputer simulation based on detailed Hubble Space Telescope data and modeled by Vanderbilt University astronomer Robert Odell. Traveling into the gigantic cloud, we see the 4 bright trapezium stars, their 3D positions now clearly evident. Their intense energy has hollowed out the nebula's center. The trapezium stars are so bright that they would blind us to the rest of the nebula if our view screen were not enhanced to show us all the details. The dark globs scattered about called proplyds, or protoplanetary disks, are blankets of dust surrounding newly formed stars, forced into teardrop shapes by energetic stellar winds from the trapezium. One of them clearly shows a ring of debris orbiting its central star, strong evidence that a new system of planets is forming. Our route out of the Orion Nebula shows us the angle at which we see it from Earth. But at 1,300 light years away, it shrinks to a minor smudge in our field of view. Imagine how it would look at only 4 light years, the distance to the nearest star.
The Orion Nebula, if we were as close to the Orion Nebula as the nearest star is to us, it would be so bright that we wouldn't be aware of the dark sky. We wouldn't see the other stars. We would almost not be aware of other galaxies just because it would be so bright. Our whole world would be the Orion Nebula and the sun.
Fortunately, we live at a point in the galaxy where our telescopes and cameras can comb the heavens to shake loose the gems we call nebulas. There are 5 major kinds. Star-forming nebulas like Orion are called H2 regions. H2 describes the thin hydrogen excited by hot stars to emit light. In other places, there are reflection nebulas, where the bright stars have driven away the surrounding gas, leaving mostly dust to reflect starlight. Planetary nebulas are formed during the slow dying stages of ordinary stars and produce some of the most intriguing displays of shape and color in the galaxy. Supernova remnants are also leftovers from stellar deaths, but from massive stars which end their lives in immense explosions. And finally, there are the dark nebulas, clouds of interstellar gas and dust, visible usually because they appear in silhouette against the bright nebulas behind them. In time, stars will burst into existence within them. But the very origin of the galaxy's clouds of stars, gas, and dust is the most intriguing phenomenon of all. Springing from the mysterious interstellar medium, the riddle of the nebulas is how they can form from what is almost nothing at all. Space and its vast emptiness has much more to it than meets the eye. Filling the distances between the sun and all its galactic neighbors is the neutral interstellar medium, or ISM.
When we think about the blackness between stars, we sometimes think there's nothing there but the vacuum of space. But actually, even the so-called vacuum of space is full of dust and gas. Now, it's quite rarefied. How rarefied? Perhaps better than the best vacuum we can create on the planet Earth.
The particles in the interstellar medium are 90% hydrogen atoms, 10% helium, and trace amounts of other elements and tiny specks of dust. Existence of the gas and dust is evident by looking at the Milky Way, the band of stars we see in the edge-on view of our home galaxy from Earth. There, the dark spaces seem to be empty, but in reality, the opposite is true.
Those spaces aren't devoid of stars. They're actually dust between us and the distant stars in the plane of our galaxy, and they block that light. And you see them in silhouette.
The black lanes of gas and dust show us where the interstellar medium is clumping together to form nebulas in their most primeval form. We see these dark nebulas as shadows against the background stars. The Snake Nebula is 650 light-years distant and approximately 3 light-years across. Even darker is Barnard 68, named for Edward Emerson Barnard, the astronomer who discovered it. Such nebulas may be deep enough to block light from stars behind them, but the gas and dust inside them is still very thin. That is, until gravity's work accelerates.
Gravity is attractive. As a consequence, we have lumps of gas, no matter how rarefied, being attracted by gravity until we have clumps of nuclear material condensing. As gravity begins to compress the gas, it starts to heat up in temperature, creating the temperatures of a star.
The new stars burst into existence, lighting up their surroundings with colorful brilliance. Remaining dark nebulas stand out in stark contrast. Like bright nebulas, their shapes suggest names. The Elephant's Trunk Nebula, the Cone Nebula, and the Flame Nebula, where dark and light areas create one of the sky's most dramatic images. The brilliant colors of the star-forming regions come from nebular gases excited by invisible ultraviolet radiation from nearby hot new stars.
The light, the ultraviolet light from those stars, is stripping off the electrons in the gas in its immediate vicinity. These electrons float around for days or weeks, and then ultimately find a bare proton or other positively charged nucleus. And they'll hop onto orbits, and as they do, they'll emit light.
At the University of Rochester, astronomer Adam Frank compares the excitement of gases in a nebula to a basketball game.
This basketball game is a real nice analogy, though earthbound, for what happens in a nebula. Down on the court, you've got Rochester going up against NYU. The basketball players are a lot like the stars at the center of a nebula. When something exciting happens on the court, you see the crowd getting all excited. The crowd stands up, they cheer, they emit energy. In this case, it's sound energy, but in the nebula, it would be light. This is exactly the same thing that happens when an electron gets ripped off an atom, flies around for a while, and then finds another atom to recombine with, and emits energy at the same time.
As new stars are born within the nebulas, they sometimes shoot out spectacular jets.